Good afternoon, everyone. I hope everybody is doing well. Sorry, I had some issues, so that's why I couldn't come on time. Yesterday, you submitted the questions. At the end of the lecture today, I'm going to illustrate the answer as well, so that you can just compare. And today, I'm just going to continue with the interest rate risk too. So there are some chapters that we need to go over. So this chapter will make discussion a market value based on for assessing and managing the interest rate risk, that we're going to use the duration itself, that you know how to calculate and how to compute it, and give some economical interpretation on that. Using the immunization system, you know how to do it, and the problems in applying the duration. So what could be done to solve those problems, like if we know how to use the duration and how to calculate, how to immunize the balance sheet itself. But there are some challenges, there are some issues that need to be solved in order to proceed with the economic interpretation of the financial position of the financial institution, actually. So in general, the longer the term of the maturity, the greater the sensitivity of the interest rate changes. And the longer the maturity of the bond has a greater drop in the price, because the payment is discounted and in a greater number of the times. So it's not only the longer the period, but in here it means as well the periodicity of the installment, the frequency of the number of the period. Like if it's not semi-annually, like quarterly, if you compare to the annual basis, then the more frequent it happens, the more discounted it will be. So the more the price will go down, or the vice versa. We know there is a relationship between the bond value and the YTM, that there is an inverse relationship. So bonds with identical maturities will respond differently to interest rate changes when the coupons differs. And this is easily to understand by recognizing that the coupon bonds consist of like bundle of zero coupon bonds. And with the higher coupons, more the bonds value generated by cash flows, which take the place sooner in time. And consequently, it is less sensitive to changes in YTM. So some remarks on preceding slides. In general, the longer the maturity, experiencing like greater price changes in response to any changes in the interest rate. So the range price is greater when the coupon is lower. 6% bond will have a large change in price response to a 2% change, and then in an 8% bond. So 6% bond has a greater interest rate risk. So let's consider two 10-year maturity instruments, a 10-year zero coupon bond and two cash flow bonds that pays $999.99 and almost immediately, and 1 penny 10 years hedge. So when it matures, if you keep it until the end, you will receive like 1 penny 10 years. So small changes in yield will have a large effect on the value of the zero, but almost no impact will be on hypothetical bonds. So most bonds are between these extremes. The higher the coupon rate, the more similar bond is to our hypothetical bond, with a higher value of the cash flow arriving sooner. So duration, we said there is a weighted average time to maturity using the relative present values of the cash flows as weight, and combines the effect differences, coupon rates, and differences in maturity based on the elasticity of the bond price with respect to the interest rate changes. And the units of durations are years, actually, that is measured. So this is how it's calculated. Macaulay duration, it's just summation of the all cash flow discounted and times by T, and divided by summation of the cash flow times discount, and you discounted them, then you just get the duration itself. It's exactly the same formulation that we used in calculation in Excel. So since the price P is the bond equals the sum of the present values, because there's one topic in here, it's very important topic that I have not introduced it in the previous chapter related to the interest rate risk too, but in here we need to cover it. so that we can proceed with the calculation. It's very important. So the price of the bond equals to the sum of the present value of all cash flow that you receive in the future. And we can state the duration formula another way, like summation of the present value of future cash flows times T divided by the price. And notice the price, I mean the bond value, okay, the current bond value. It is the summation of all annual future cash flow, which is discounted with a par value itself, and you come up with a duration, okay? It's just rearrangement of the formulation in this way. Okay, if it's semi-annually, we know how to deal with the semi-annually. We divide all the rates by 2, and we're multiplying the times by 2. This is the semi. If it's 4 years, then if it's semi-annual, it's gonna be 8 periodic payments. So for zero coupon bond, macro duration equals to maturity since 100% of its present value is generated by the payment of the face value. So that's why whatever is maturity for zero coupon bond, it is the same as duration. Okay, for all other bonds, duration is less than maturity always. Okay, and consider the 2-year 8% coupon bond with a face value of 1,000. The yield to maturity is 12%, and coupons are paid semi-annually. Therefore, each coupon payment is $40 per period, and YTM is divided by 2, which was 12% on annual basis. Now, if it's semi-annual, it's 6%. So present value of each cash flow equals to, if you want to discount it, where T is the period of the number which is used in here. If it's 2 years, then it's going to happen 4. So this is how we calculate it. We're given the years. Like if it's just 2 years bonds and it's semi-annually, like for frequency in it's 4 times, and 40 40 40 it's coupon payment, and this all the things, and this is the bond value. Okay, bond value. So this is how we calculate the duration, is the weighted average times by years. 1,770 divided by 1,000, you would get duration equal to 1.83. So for normal bonds, as it has been mentioned, that the duration is always less than maturity. Okay, duration is always less than the maturity. But for the zero coupon bond, duration is exactly equal to maturity. So the maturity of the console perpetuity is equal to, like, that means it's infinite. It doesn't have any fixed number of the years. So duration of the console, which is perpetuity, is 1 plus 1 over R. This will give you the duration of the perpetuity. So duration and the maturity, as duration increases with the maturity, but it's at decreasing rate. So duration and yield to maturity, D decreases as yield to maturity increases. This relationship we already figured out by calculating different cases at the end of the chapter. So duration, the coupon interest rate, duration decreases as the coupon increases. Okay. So duration is the measure of the interest rate sensitivity, or we can say it's elasticity of the liability or elasticity of the asset. So duration is equal to change in price divided by the interest rate shock, or equivalently we can rewrite it like change in price, like price sensitivity, and is equal to duration times the relative change in interest rate. So that duration and relative change in interest, if you rearrange it, may come with modified duration times change in interest. Okay, change in interest. So to estimate the change in the price, we can rewrite this as change in price is equal to duration is times by change in R. So this is relative change interest times by relative change interest and times by P. Or it is like modified duration times change in interest and times price. And this will give you the change in price. And one thing that I want to underline, this is the case we're trying to see, it's kind of we're using by how much your price of the bond will change if the interest changes by this much, okay? And this is the way why these things are given is to kind of predict the price. However, with one condition in here, the prediction of the price has got the future of a linear relationship, okay? See, there is a direct linear relationship. So it's not like reliable as much when there is like a dynamic relationship. So we should take into consideration some other factors and some other components in order to come up with a more real picture of the change in the price. So we'll have some examples to solve to find out how the change in the interest rate will affect the change in the price, kind of prediction of the price of the bond, in what direction the bond will go. Because if the interest rate increases by 2%, in linear relationship, it shows that the change in price will go by 2% the same, okay? I mean, this is not the case of the reality. So the dollar duration equals to modified duration times price. Using dollar duration, we can compute the change in price. So change in price is equal to dollar duration times change in interest. So this will give you change in price. So we're just kind of rearranging. Yes, please. Yes.
Modified duration means like leverage adjusted duration, yes?
Yes, yes, very true, very true. Okay. And this is the case of the semi-annual coupon bonds. Okay, when we apply the semi-annual cases, sensitivity of the price changes with the relation change in the relative change in interest rate with the semi-annual basis. So the matching the maturity of an asset investment with a future payout responsibility does not necessarily actually remove the interest rate risk from the financial institution. So the matching durations is always the case that you're trying to immunize against the changes in the interest rate, okay? You're trying to reduce the effect of the interest rate changes, but you cannot eliminate fully. So consider 3 loans plans, okay, all of which have the maturity of 3 years. The loan amount is $1,000 and the current interest rate is 3%. So the first loan is a 2-payment loan with the 2 equal payments, like $522 each. This is the first loan. The second loan is structured as 3% annual coupon bonds, like 3% payment of coupon payment and with the face value. And the loan 3 is the discount loan, which has a single payment of $1,060.90. So you buy it at discount and then you sell it at this price. So these are how it looks like. So equal payments. And this is the value actually, okay? So if interest rate was 3%, the value of this loan is $1,000 in all cases, like in all 3 types of loans, you can see it. Look what happens. You know, the components of the loans, the features of the loan, the ingredients of the loans of these 3 different loans are the same, but the method, the manner of the payment is different, okay, with some differentiation. So what happens if YTM falls from 3% to 2%? Look what happens to the value. When it's equal payment, the value actually increases to $1,014.68, and there's a change in price. We can count it. It's $14.68, and here we have change. The price becomes here. The change in price will be $19.42. So it becomes $1,019.42. And the third type of loan, it changed by 19.70. This. So in here we can come up with the conclusion that change in the interest rate is taking into consideration the duration itself. The higher the duration, the more change in the price we should expect. Okay, so the higher the duration, that means the change in the price or the bond, that bond will be more sensitive to the interest rate changes. This is what it implies to actually. So duration is the measure of interest rate risk exposure for a financial institution. If the duration of liabilities and the assets are not matched, then there is a risk that the adverse changes in interest rate will increase the present value of liabilities more than the present value of assets is increased. And this we justified with some calculations in the chapter, at the end of the chapter. So we went through the questions. By the way, I already uploaded those questions that we already went through. And if you still have some questions, and please follow the video which is uploaded. You can use that video to see it. So duration gap. Suppose that 2-year coupon bond is only the loan asset for a financial institution, and a 2-year certificate of deposit is the only liability. If duration of the coupon bond is 1.8 years, okay, then the maturity gap 2 minus 2 is 0. So the maturity are the same, 2 years and 2 years, so directly 0. But duration gap is 1.8 minus 2, which is minus 0.2. So there is a inverse, the negative number. So deposit has greater interest rate sensitivity than the bond. So duration gap is negative. So financial institution is exposed to increase in the interest rate, because increase in the interest rate, that will mean that changes in liability side will be higher than the changes on the asset side. So that will lead to reduction in the equity, in the net worth of the financial institution. So from the balance sheet, we know that equity is equal asset minus liability. So we can find out the change in equity is equal to change in asset minus change in liability. So in the same manner, it is used to determine the change in the bond price. We can find the change in the value of the equity using the duration, okay? So this is formula that you are already familiar. I already introduced you that it has got 3 components. One is, the first component is leverage adjusted duration. Second component is the asset size. And the third component is interest rate shock, like change in the interest, like relative change in the interest. So these 3 components are affecting the equity itself, the net worth of the bank. So here's some examples given. We already solved already in the book, but let me just proceed with this example as well. The duration of 5 years, duration of liability 3 years, and rates are expected to rise from 10% to 11%. So also asset is equal 100, liability is equal to 90, and equity is equal to 10. So what is the change in net worth of the financial institution? If you apply into the formula, you just substitute all the numbers, and we're gonna come up with minus 2.09. So there's a negative change in the equity, okay? If interest rate changes by 1%, so increase in the interest rate. Increase in the interest rate, that shows that will affect your equity in opposite direction. If you had like negative duration, like if you had the duration liability higher than the duration of your asset, then definitely the change in the net worth would be the opposite action. So the methods of immunizing the balance sheet is adjusting the duration of assets. Okay, you just adjust the duration of assets or duration liability, or you can adjust the key. The key is the liability over the assets. So the regulators set target ratio for financial institutions capital. and capital ratio is equity over asset. So target is to set change in equity and asset equal to 0. So that means duration of asset is equal to duration liabilities. So, but when you set this change in equity is equal to 0, that would equate minus duration A to K times by duration liability. So this is the thing that you should keep in mind, this formula. So immunizing the entire balance sheet need not be costly actually, and duration can be employed by combination with the hedge position to immunize it. So immunization is a dynamic process since the duration depends on instantaneous R, and R is representing the required rate of return, the interest rate. And large interest rate change effects not accurately captured. So we need to take into consideration the issue like convexity. And the convexity, it measures the relationship. More specifically, convexity is measuring dynamic relationship between bond value and the YTM. So if I wanted to illustrate this on the graph, for example, not in here, but it's better to illustrate on. For you to understand better what I mean by convexity.
Excuse me, Professor.
Yes,
the sound is lagging.
I can't hear you. Your sound is lagging as well. Can you hear me now? Or it's lagging?
No, your sound is okay. It's just his internet connection may be very weak.
Yes, unfortunately. So let me draw it. Bond value and YTM. So this is, it shows a direct linear relationship, okay? Any increase, any change in price, it will be proportional change in proportional change in interest rate, okay? If interest rate YTM changes, the price will change proportionally. This is what it shows in a linear, in direct linear relationship. But when it comes to convexity, it says that the relationship between the bond value and YTM is not the linear, it's the curvature. Curvature, it means that it changes, it goes like this. Okay, it's a kind of convex, it's a U-shaped curve, okay, U-shaped curve. So any change before this point, any change in here, in price or in interest rate, it will be underestimating the bond value, okay? The bond value will be underestimated. If the change in YTM happens in this region, that means that change will affect the bond value and we will overestimate the change in the price. So that means that we should not ignore the convexity, the curvature manner, the curvature feature of this relationship. So this is very important. The YTM, so the yield curve is not in this way, okay? There is no linear relationship. In real practice, the researchers, they found it out that curvature, the convexity feature is giving you more clear and more realistic prediction in price in bond value. So this is more realistic picture of predicting the bond value actually. So we need to use the convexity when we predict the change in the price. So we'll have some examples when we use linear direct relationship and we're predicting the price, and when we will predict the price using the convexity. So the problem with duration, immunizing the entire balance sheet need not to be like it's a very big problem, and it does not include the convexity. That's why the convexity should be taken into consideration, okay, while calculating. So convexity, so it is basically, as I said, the duration is the measure of the linear approximation of non-linear function. If there are large changes in interest rate, the approximation is much less accurate. And so you need to be very careful when you do the economic interpretation of your results. All fixed income securities are convex, and convexity is desirable, but greater convexity causes the larger error. So you should be very careful with use of the convexity as well. In duration-based estimate of price changes as well. Those who are familiar with the calculus may recognize that duration involves only the first derivative of the price function. And we can improve on the estimate using the Taylor expansion. In practice, the expansion rarely goes beyond the second derivative. And second order expansion is the convexity adjustment. So this is the formula is given. Change in price divided price. It gives you the sensitivity of the price, time equal to duration times the relative change in interest rate, plus 1/2 of convexity effect or curvature effect times change in interest rate squared to the power of 2. Or if you rearrange it everything, here we go, modified duration times change in R plus 1/2 convexity times change in R. So where MD is equal to modified duration, Cx is measured of curvature effect. The curvature is like U-shaped curve, okay? This is what it means. And Cx is equal to, like if you want to find the Cx, curvature effect is a scaling factor times the capital loss from 1 basis point rise in the yield and plus capital gain from 1 BP fall in yield. So commonly used scaling factor is equal to 10 to the power 8. So example of the convexity is given here. So a convexity of 8% of coupon and 8% yield, 6-year maturity Eurobond and price at $1,000. So convexity is equal to, here we go, scaling factor, change in price divided by P plus change in price plus divided by P. So it's a positive change, it's a negative change, okay? And your convexity is equal to, the curvature effect is equal to 28. So we'll have more example with the Cx, then you will understand what is really. So we'll try to compare by how much it accurately measures the price, by how much accurately it measures the effect of convexity on the price, on changes on interest relative to price changes actually. So interest rate changes also affect the value of balance sheet claims. So duration gap hedging strategy must include the effects of off-balance sheet items as well, such as future option swaps, caps, loan commitments, other contingent claims. Okay. We're gonna.
Professor.
Yes.
When do off-balance sheet assets become on-balance sheet assets?
We will come to that topic. It depends when it's like options and the futures. Options are kind of give you the option to exercise the option or not. If you exercise it, it becomes on balance sheet. If you don't exercise, it doesn't become on. Okay. Same thing with the loan commitment. We will come to this in more details. We'll come to this in more detail in next week. In next week, okay? Once we
Okay.
next week we're gonna go through it. Okay, this was the example of convexity. So we'll have more examples on the convexity tomorrow. But now I want to share with you. This chapter is uploaded in Moodle. Once we go through the examples, it will make us to understand better, actually. Where is that example? Let me. My gosh. I think this was the question, yes? This was the question yesterday. I just shared with you. Now, what is the case in here? Information is given here. So treasury bond is 5-year maturity, paying 6% semi-annual and selling at par. So what is the duration of the T bond? Okay, T bond. We know it's being sold, and you can do it using the Excel. I'm not gonna do it in Excel. You know how to do it. I'm just gonna give you the direct answer. So you just you take the cash flows, like cash flow. Let me open this. Okay. Part A. So you arrange in this way: time, cash flow, discounted cash flow, what you found it when you discount it, and discounted cash flow times by T, the period, which will be here. Okay. So it starts from 0.5. It's why 0.5? Because it's semi-annually, and it's 6 years. If not, yeah, 5 years. Sorry, 5 years, like 10 periods. And cash flow will be 5.28. It's a coupon payment. And what is the par value? Is $176, and 6% of 176 is equal to this. So if you discount this, it's gonna happen. If you discount with the same rate, interest rate is the same because it's being sold, it's being traded at the same price, at its par. So discounted cash flow, it's if you multiply times T, 2.56. And the summation, so 5 like 5 years. In here you have 181.28 and 134.89. And if you just multiply, you're gonna have 674.45. And in total, you're gonna have, so this discounted cash flow is equal to 176. If you just sum it all, okay, if you sum it all, you're gonna have 176. And if you sum this all, you're gonna have 773.80, and duration is equal to 773.18 divided by 176, which is 4.3931 years. Okay, this was part A. Part B. Part B, what is the average duration of the all assets? So we need to take the weighted average. All the weighted averages are given here. Okay. Now we found the duration for T-bond here. You can just substitute and you know how to do it, like 90 times 0.5, 55 times 0.90. This is how you just make it, and 4.3931 years times 176 and so on. You continue. So the average duration, average duration is equal to 6.54 years. Part C. In part C, what is the average duration of all liabilities? Okay, this is for all assets. Okay, and the liabilities are starting in here, guys. It starts from deposit, Fed funds. So there are two components of the liability. And of course, when you get this one, to remind you, duration of assets, average duration of assets should be divided by the number of the observation you're using. If you use like 5, 1, 2, 3, 4 number of observation, that means it should be divided by total assets. Okay, it should be divided by total assets. You add them up and it should be divided by this. And liabilities, they should be divided by total asset as well. Sorry, average duration is equal to 0.8989 years. So average duration, let me put that, just a second, let me put it. Just beginning so that you don't get confused. 0.90 times 0.5 plus and loans, which is 2,774 times 7, and this is much what we get it, and this all is divided by the average total asset, which is in here. If you add them up all, that will give you 3,045. And in here, duration of averages, the same thing. We're using just two components in here: deposits, 2,092 times 1 and 238 times 001. So 2,092 times 1 plus 238 times 0.01. And of course, this should be divided by the average, by the total number of observation, okay, by the average of it. So which means if you add them up, this 2,092 plus 238, it should give you the summation, and this number should use as a denominator in here. So if you add them up, 2,330. Do you have any questions? Okay, what is the part D? What is the leverage adjusted duration gap? So what is the leverage adjusted duration gap? And what is the interest rate exposure to it? So we know that duration gap is equal to duration of asset minus duration of liability times K. This will give you the leverage adjusted duration gap. And I will not put the formula. We know how to calculate. So adjusted duration gap like leverage 1 is equal to 6.54 minus, let me just put the answer, you know, it's, you just substitute all the numbers, okay? You just substitute all the numbers, that will give you the 5.8592 years. So duration gap in here, we have positive sign. That shows that increase in the interest rate will bring a decrease in the market value of the equity actually. And we know that before we know the duration gap has got three components, like minus adjusted leverage adjusted duration gap times size times interest rate shock, okay? And this minus means that increase in the interest rate will bring the change in the equity. So the change in equity, you know the formulation already, we just talked about it. Yes. And part E. What is the forecasted impact on the market value of equity caused by a relative upward shift entire yield curve of 0.5%? Like the interest rate shock is here, 5 basis points. So what will happen to change in market value equity? So minus leverage adjusted duration gap times size times relative shock of interest, okay? This is what we know it actually. So change in equity is equal to leverage adjusted duration gap, which is minus here, minus 5.8592 times the size of the assets, which is 3045, times change in by 5 basis points, but it increases, okay? There's an increase. So upward, it shifts upward, so 0.005. So the interest rate shock has got positive shock, but however, that positive will trigger down your equity. So your equity will be equal to minus 89.207. Okay. In part F, the yield curve shift downward by 0.25%, like 25 basis point it decreases. So interest rate shock has got negative patterns. So what will be the forecasted impact on the market value of equity? So how much your change in equity happens? So change in equity is equal adjusted duration gap, which is minus 5.8592 times 3045, and this times with a negative number minus 0.025, and that should bring you actually positive number, and it is equal to if you calculate times by 3045 times minus 0.25, and it will be equal to 44,603. Yeah, 44,603,000. Okay, this much your equity will be appreciated. So that means your equity will go up. And the last part, Oops, sorry. Guys, I will let you know. I will let you go. I know the time is over, but give me more minutes. The last part, okay? I'm just gonna make comment on that. That's it. What variables are available for financial institution to immunize the balance sheet, and how much would each variable to need to change to get the duration gap equal to 0? So immunization actually requires the bank to have the leverage adjusted duration gap equal to 0. So financial institution could reduce the duration of assets by using more T-bills and floating rates, we can say. And how to reduce to this, we can play out with by how much to what level it should be reduced. We can just play around. We can mathematically come up with duration of asset is equal K times duration of liabilities. So this much should be the duration of asset actually, in order to make the adjusted duration gap equal to 0. And if financial institution could try to increase the duration of its deposits, that may help as well. And finally, the financial institution could use combination, reducing asset duration and increasing the liability duration in such manner that duration gap is equal to 0. So you can play. And duration gap of 5.8592 years is quite large, and it is not likely that the financial institution will be able to reduce it to 0 by using only duration of asset. Still would exceed the duration of the liabilities after adjusting for leverage. So that means that you have to use combination, the asset and the liability sides. So this adjustment in asset mix would imply the foregoing the large yield of advantage, long portfolio, and relative T-bill yields in most economic environments. So you have to basically, in order to reduce it to close to 0, still it's not possible, it's too large, but still it's possible, but not to 0, at least close to 0. Play with the liabilities and the assets. Okay, this is all. Thank you for your attention, guys. And that's it. If you have any questions.
Yeah, I have a question.
Yes, please.
Yeah, you can go first.
Thank you. Professor, did you upload those Excel files with the solved problems?
I already uploaded. It's in there.
Oh, thank you.
It's there already.
And can I ask you?
Yes, please.
Question B and C. Do we consider loans as an asset and Fed funds as liabilities?
Okay, just a second. Let me go. To the balance sheet. Now, here the important thing that you know that the assets, the balance sheet, it's like has got two different way of illustration. It like one is like going from up to down, from asset to liability side. So until here, we never consider the loans. We never consider the loans as liability. We always consider the loans as assets. And the liability, they always start with deposits, okay? CD and so on. And Fed funds can be asset and liabilities. As it goes in here after deposits, then it's a liability. So asset here until this line, then liability, and then we have equity.
Okay, thank you.
You're welcome.
I also have a question.
Yes, please.
Could you repeat the part about interest risk exposure? It was the question number.
If you just remind me, please, where was it?
D or E?
Here in the question. I thought you were talking about the slides. Okay, now.
No.
what is the
And the
interest
fee.
rate is risk exposure? Okay, now we got here positive adjusted leverage. Okay,
Mhm.
so what is the interest rate risk exposure we should expect in here? Increase or decrease? So when it said interest rate risk exposure, it means that what financial institution will face, and when the financial institution will have a problem, when the financial institution will have a reduction in equity, that will reduce the equity. So what will happen to the interest? That means that the interest rate go up or down. If you have leverage adjusted duration gap equal, if it's positive, that means financial institutions are exposed to interest rate increase risk. Okay, so increasing in interest rate, that will cause the equity to go down, because changing the equity, you know, the formulation is equal to minus duration adjusted leverage duration gap times A times relative change in interest. So that positive increase will lead down the equity.
Yes, thank you. I understood.
Okay, I have a question regarding our midterm exam. How many problems there will be, and how many theoretical questions you're gonna include? So actually, I'm gonna combine the theoretical question with calculation. As we know that we discussed, you get results and you have to be able to interpret. And how many questions? Honestly, I have not decided. Most probably, you're gonna have 5 questions. But in timing, you will have 2 hours. In 2 hours, you have to solve it and submit. Open book, that's it. I will talk about it more on Friday. I'll talk about it more on Friday, okay? On Friday when we meet, we're gonna talk about it more.
Okay, thank you. Goodbye.
You're welcome. Bye. Bye.
Excuse me, Professor.
Yes?
Excuse me.
Yes.
I forgot to ask on corporate finance class, about corporate finance class. It's like same, right? Like 2 hours. So,
Yeah. Same. It's gonna be 2 hours, and more or less you'll have 5 questions as well.
oh, okay, I got it. And there will, it will include first chapters, right? First 3, or how many?
In here, in corporate finance, you will have 2 chapters.
2?
Capital budgeting and cost of capital in corporate finance. In this course, you have 4 chapters.
Okay. Capital budgeting and
Cost of capital.
what's it?
Cost of capital.
Okay, I got it.
Okay.
Yeah, I got it. Have a good day, sir. Goodbye.
You too. Bye. Bye. Take care.